to another episode of eXpose Experience. Today, this episode is brought to you by Coffee and Always a Handful Cakes. And we have our guest here today. Please introduce yourself.
Hello, hi everyone. My name is Lim Jing from Osteopore International.
Hi.
I'm the Chief Technology Officer at the company.
Well, it's a privilege for us to have a CTO for eXpose Experience. We have
Nice
never
to
had
be
a
here.
Chief Technology Officer coming
is it?
on our show.
Okay.
So you are the
First.
first.
Thank you.
And for those who are unaware, Lim Jing here is also a PhD holder.
Yeah, I got my PhD in 2014 from NTU, from the Division of Bioengineering.
So he is a doctor.
Bioengineering. Okay.
Wow.
Can you tell me a bit more about the things you do or like your field a bit for our viewers here?
You mean for bioengineering? Or like the work?
The work lah.
The work. Okay, so what the company does is we use 3D printing, which is now quite the hype, right, in the industry, and we apply it in the medical industry to make implants.
Okay.
Yeah, so the implants that we design and develop will be going into patients in order to allow them to regenerate their own bone.
Wow.
Yeah, so as the implant allows tissue regeneration, the material disappears away in the body.
Oh.
So at the end of about 18 to 24 months, all that is left is just the patient's own tissue. So there's no more foreign material left in the body.
Wow.
Yeah.
Oh.
Yeah.
Very
Wow.
interesting.
Yeah, it's a technology that came out of a collaboration between scientists and clinicians.
Okay.
Yeah, and that happened. We started that research in 1996,
Okay.
and then after a period of about 6 to 7 years, they realized that the technology was ready for so-called commercialization.
Oh.
So they
okay.
formed a company, the 6 of them, and that's where Osteopore was formed. That's 2003,
I
somewhere in
see.
November.
Okay.
Yeah.
And this is sold purely made in Singapore, founded in Singapore.
Yes, that's right. So
Wow.
it's a Singapore technology that came out of a collaboration between the university and the polytechnic.
Okay.
And then since that time when the company was founded, other universities have also joined in to develop products with us.
Okay.
Yeah,
okay.
so there are new intellectual property, there are new products that are developed as a result of our collaboration.
I see.
Mm-hmm.
Wow.
Okay.
So, ladies and gentlemen, you see, we do have Singapore startups who are doing very cool things. All right, tissue regeneration or helping tissues to regenerate. I would say, would it be in a more sustainable manner, in a more non-invasive manner?
I guess the idea is that the founding team, they actually saw some gaps in the clinical community, particularly when you put implants in patients. Because right now the traditional way of reconstructing bone defects, generally speaking, is you put titanium or a non-absorbable polymer or plastic.
Okay.
Right?
Yeah,
So
that's
the
right.
common word for a polymer is a plastic. So you can stick it in the body. It doesn't cause any adverse interactions with the surrounding tissue, but then it's a permanent device that's always in the body until you pass on. Right? And then the unfortunate thing is that even though, at the point where you implant this,
Yes.
there is no reaction. Sometimes there's a possibility that maybe 5 or 8 years after surgery, they may develop some reactions. So at that point, the patient has to be called back to the hospital. Then the surgeon may have to make a decision whether to remove the implant and replace it with another one.
Wow. Okay.
Yeah, so it can be quite traumatic for the patient because you imagine having to redo your surgery, right?
Yes.
So that's where they had the idea of why not, if we can implant something that
Yes.
allows tissue to grow back, and then the patient won't have that concern in the long term that I have to redo or I have to come back for another surgery.
I see. Okay.
Yeah. So the whole objective is to improve the quality of life of the patient.
Okay.
Yeah.
And I guess it definitely does, because then as a patient myself, I don't have to worry about what the repercussion that may happen to me 5 or 6
Correct.
years down the road.
Correct.
If
And
it was I've been with titanium
Yeah.
Yep.
screws,
It's a foreign
etc.
material.
Yes.
Correct.
Yeah.
I guess because it it also has some advantage for the overall for the hospital system, because sometimes, I mean, before COVID lah, then we had all these bed crunch.
Yes.
There were not enough beds in the hospitals, not enough wards for patients, right? So if we are able to, let's say, reduce having to readmit the patient, and then go through a surgery and then have them stay in the ward for another time, then actually these spaces can be freed up. And then all the emergency patients or the patients that actually need to get urgent medical treatment can then have the bed space. So that's what we are trying to do on the hospital's side of things. Yeah.
So you're actually solving multiple problems from
so
the
I mean,
patient to the hospital system.
Correct. So of course, we are still a very small company, and the use of the products are limited to certain scenarios. But I think in whatever small way we can contribute to the entire ecosystem, we try to help.
Wow, that's a very intentional purpose, I guess.
So I mean, we figure it out along the way. Figure out along the way. I mean, at the beginning, it was just really thinking about, okay, what can we resolve that problem of having these late complications. But along the way, then you figure out, hey, actually it has more users. It can help this cause and that cause.
I see. And tell me a bit about you. How do you get involved in Osteopore as a Chief Technology Officer?
Oh, okay.
Yeah.
So the professor that I work with in NTU, and previously before that in NUS, he was actually one of the founding members of the company.
Okay.
Yeah. So he took me under his guidance, and then from an educational and academic point of view, so then I learned more on the scientific aspect of the technology from him when I was still a student.
Okay.
And then when I did my postgraduate degrees, it was mostly working on anything that is related to tissue growth or tissue regeneration. So somewhere in about 2011 was when I was exposed to a variety of surgeons. So I was exposed to cardiothoracic surgeons, I was exposed to vascular surgeons, plastic surgeons, neurosurgeons, and subsequently, more and more different specialties that I interacted with. And then by the time I finished my PhD, then he asked me whether I have an intention to join the company. So I thought it was, for a researcher to see your research topic come into reality and being applied in humans, that's usually a dream come true. So I think it was one of the motivating factors for me to join.
So do you do your PhD and in the meantime audition for that role throughout the period?
Well, it was not intentional, I must say. Of course, when you start on a postgraduate degree, then you probably think of, maybe after I get my qualification, then your next step would be, let's stay in the research field. You continue your research. Then if and when a chance occurs and happens, then you take up a professorship, that kind of track, or you could go into lecturing. So that was mostly on the minds of people.
I see.
Then I think for myself, it was just that the opportunity presented itself.
Okay.
Then I thought, why not just give it a try? So when I came into the company, we were mostly focused on stabilizing our regulatory compliance, as well as a bit of our production manufacturing side of things. And then I think that's where we started off.
I see.
So when I came in, it was in the role of an engineer. So I was hired as a product development engineer.
I see. And you worked your way to...
over the years.
I see.
So, aside from that, what were some challenges that you might have faced through the years, and how do you overcome them in this?
So it's a very broad question. So there were really quite a few challenges that we had to face and contend with. So I think at the beginning was you had a lack of resource sometimes, and it becomes very difficult to execute certain things. Because you are in a company, so every company is profit driven, right?
Yes.
You need to be selling something in order to sustain the business. So when I came in, so my own personal challenges along the way was the regulatory affairs. Yeah, so that involves getting your certifications from ISO. Yeah, so that was one of the challenges that I had to overcome.
Okay.
And then subsequently would be to see how we can reapproach or approach the market again. Yeah, because the reason why the company took quite a few number of years to grow is because they actually have been incubating the technology.
I see.
Yeah, so it's very rare to have a Asian or a Singapore medical device company being first in the world. So most of the medical device players, the major ones are from US and Europe. Yeah, so if you go out with a Singapore brand, typically you don't have that power and that authority. So from 2003 until 2014, there have been some small and limited use in hospitals, but mostly they were trying to prove that the results are good.
I see.
So when we joined, somewhere in 2015, we started the collection of data from local hospitals.
Okay.
Yeah, because we realized that there is actually a 10-year history of using the product.
Okay.
Yeah, so a few years on, we collected everything, and now there are 3 published articles,
Okay.
internationally peer-reviewed. Yeah, that proves that the device is safe, it is effective, right? And then we use that to support all the messages that we're trying to bring out. So I think that was one of the other challenges, how we approach. So we strategized our approach, then we went out to execute that with the resources that we had.
I see.
And then I think after that, we also stabilized the regional part of it, which is to either review or reselect our partners and distributors in other countries. Because at that point in time, we were already selling overseas. It's just that it was kind of limited as well. Yeah, so I think the new management team came in, they relooked at that distribution business, and then they reselected or renewed partnerships.
Okay.
So that helped to stabilize everything.
I see.
Yeah.
So it's a long drawn process of constantly trying, learning from failures, trying again.
Yeah, I think the key is you have to try lah. Yeah, I mean we can plan a lot on paper, but you won't know whether it works or doesn't work until you actually try it yourself. Yeah, so I think the key really is to try and give a shot.
Okay.
And then correct it from there if it's wrong, and build on it if it's successful.
I see.
Yeah, that's the reality of things.
Correct.
People think it's all the fluff and the result.
Yeah,
but the reality of things is really
correct.
Gotta keep trying.
Long years of work. Yeah.
So in a lot of public's perception, right, is like a medical device, etc., or things that do deal with medical, anything that is dealing with medical, seems to take very long to go to market, right? So, and from what you are saying, it is true, right? In that sense that it does take time, and you are literally in a position where you can't really make a mistake once the product is pushed out to the public. Am I right to
So because medical devices, you have different risk classifications. So some of them are considered low risk. Some are generally termed as medium risk, and then some are considered high risk or life-sustaining kind of devices. So generally, the higher the risk classification, then the longer or the more difficult it is to get to market.
Okay.
So things like wearables, probably you have a pretty short product life cycle. You can probably get to market faster because those are considered low risk. But if you talk about life-sustaining devices like heart valves, stents, so those kind of things will probably require more data in order to establish the safety profile of your device, and therefore the process is longer. But the funny thing in medical devices industry, especially the implantable ones, is that it's a bit like wine. The longer you keep it for, then the better tasting it gets.
Okay.
Right, in the right conditions.
Interesting. Okay.
Yeah. So if you think about it, if you have probably a new technology, new device, that's probably just approved to sell in the market, versus you have one that has an established 20-30 year history.
Yeah.
Right, so that amount of data actually substantiates why the product is still there, and that is why this information is very important.
I see.
For device companies.
So it is very much data driven as well.
Correct. Yeah. So you need to show that you have this information. From the information, your surgeons who are your customers should be able to make informed decisions on whether to use that implant on a particular patient, how to use it.
I see.
Yeah.
Okay. And do you all do a lot of engagement with the surgeons face to face or?
Yep.
To collect all this.
Correct. So you have to initiate that discussion.
Okay.
And therefore there is a lot of requirement on internal training.
I see.
Yeah, because you will carry out that conversation either through your own sales representative or product representatives, or maybe sometimes with your distributors and your partners overseas.
I see.
So then this element of training has to come through, so that when your representatives meet with the customers, then they can start the topic, and start the discussion. Then you can have the data that comes in.
Okay. And also these surgeons will then convey the so-called the message to the patient, right? When they recommend the procedures that will require Osteopore's product.
Yeah. So they will probably give the patients a list of things that could be used to treat such problems, and then they will probably explain what each of these devices can do.
I see.
Sometimes they talk about the price, sometimes they talk about the technology, the outcomes. And then in some cases they can make recommendations, and in other cases they also, if it's not non-critical, they might let the patient and the family have a think about it and whether you want to choose one over the other.
Okay.
Yeah. So this thing is very dependent on market. So the way Singapore does things and the way Malaysia does things or the way Vietnam does things is going to be very different. Yeah. So you kind of have to cater for
Different
individual market needs lah. Because I mean the truth in this area is that you have maybe if you add up all the land mass lah, you're probably as big as the US, but you have inside you have a lot of cultures, right? Different languages that you have to get through. So it's very different selling here than if you're selling a big geographical space, but they are generally the same culture, speaking the same language.
I see.
Yeah, so challenges are a bit different.
I see. So for the viewers of eXpose, right? How would you explain the device that that Osteopore produces, right? To help in that replacement and then subsequently dissolve, right? So basically, what I'm trying to say is like in layman's term. How would you explain?
Very interesting.
It's very interesting.
Okay, so actually, if you look into our human bone, right? What we see on the outside is that it's completely a solid piece, lah.
Yes.
Right. But actually, if you look in, it's very porous. There are a lot of holes inside.
Okay.
Yeah.
Really?
Yeah. So that's
human bone.
You don't have to. It doesn't have to be human bone. Can be any animal bone. So if you get it fresh and you look on the inside, so you cut it across the cross-sectional area, you look in. Actually, there's something called a canal inside. Yeah, that's where your marrow is.
I see.
The marrow. Yeah, and then surrounding it, you have a lot of net-like structures.
Okay.
Yeah.
So it's a bit like some corals. They
correct. They look like that.
Can I? Is it like when you eat tulang?
Yes, it is exactly like that. It's exactly like that.
Okay.
Oh, okay.
Yeah, it's exactly like that.
Okay.
Yeah. So actually that part where it's very porous, and then that marrow part, right, spongy part, right. So that is the most active part of bone. So if you let's say get an injury, you knock on you get a bruise, and then it needs to be you don't usually see a doctor for it because your bone will heal itself. But the healing power comes from inside.
Oh, okay.
Yeah, so it doesn't come from the part that you feel is very hard. The healing power comes from the inside.
So it's the inside that
correct.
Basically
heals. Provides the healing power to
okay.
Wow. Okay.
So then when the founding members of the company looked into this, they said, then in this case we should try to recreate that structure.
I see.
Right? You want to recreate that structure.
Okay.
So then I think sometimes we get questions about why do you use 3D printing?
Yeah.
So at the point in time where they conceived this idea that, oh, we want to recreate this structure, it is almost impossible to use traditional manufacturing
Okay.
techniques to do it. Yeah, because if you look at your plastic bottles, they are probably blow molded out.
Yep.
They either could be injection molding. Then these are very high volume, but you can't get these very intricate structures because the technology doesn't allow it to happen.
Yeah, I see.
So additive manufacturing or 3D printing actually existed like since long time ago, but most of the people only use it to prototype. So like I need to make a quick part and discuss with a customer,
Yes.
right? So I'll 3D print one part, I bring it to you. Then once you confirm, then we injection mold or we whatever.
Yes.
Right? So it was mostly used as a prototyping tool. And at that time, they said the only way we can make it to an actual product is to 3D print it.
Okay.
So back at that time, whatever you can get your hands on for the 3D printer, then they got that from a research fund.
Okay.
And then they started the development.
Wow.
So actually what you see as the product would be something that has layers. And it's of course regular because you can control the architecture. So you print it regularly into, we call it a lattice like structure.
Okay.
So it's 3-dimensional.
Yeah.
Then from there, they carried out some investigation by putting cells on it.
Okay.
Right,
Okay.
to check the interaction.
Yeah.
Then over time, they realized that, hey, you know, this current structure that we have is really very friendly to cells. They like to live inside. They like to grow. They like to populate the entire space.
Okay.
So then we can actually make an implant out of it.
Okay.
Yeah, so then from there it went into animal studies. Yeah, because that's the next natural phase of progression
I
for
see.
device testing. So you, under ethics approval, you put it in animals. And then they realized that the results were very, very positive.
Okay.
So they said, okay, then really this thing can grow bone. Yeah.
Okay.
Wow. Okay.
Yeah, then I think at that point they said, okay, we need to spin off the company and
I
and that's where the
see.
rest is history lah. Yeah.
So
3D
the 3D printing portion actually came out of as a solution
Correct.
to a problem rather than the idea.
Yeah. So it wasn't
Per se.
that because 3D printing is a very nice and sexy
okay.
thing, so we wanted to do 3D printing. So it was reversed lah. It was like, okay, we needed to get this.
Yes.
But the only way we can get that is use 3D printing.
To use 3D printing.
Yeah. So
okay.
because I think nowadays when everyone mentions 3D printing, it's usually like personalized, customized.
Yes.
I think that's most of the time what it goes to. But for us, our business, 95% is standard produced parts.
Okay.
Customized parts are less than 5%.
I see.
Yeah.
Standard.
Yeah.
produce.
Standard produced parts means you can produce them in volume. They are always about the same shape or size. Yeah, and it doesn't rely on a patient's anatomy or the bone defect shape or size. So the customized ones are when it's irregular.
Yeah.
And then they have a specific patient need.
I see.
So then we customize it. Yeah, but for us at this moment, most of it is standard produce.
Standard producer.
Yeah.
Okay.
3D printing. Yeah, it makes sense because 3D printing, from what I know, is by like the software, like
Yes,
algorithms,
that's
right.
like,
Yeah,
it's really quite accurate from what I've seen and what I've experienced and observed. So it makes sense to use 3D printing. Yeah.
I see. Wow. Okay. And what, apart from medical use, right, are there other uses for this as well, like aesthetics or anything along that way?
Okay, so generally 3D printing has been pretty well accepted in the last few years for the medical community.
Yeah.
So what they have done with it is, first, at a very basic level, they have used it to 3D print maybe the patient's anatomy. And then one of the very well-known things that well-publicized local news is KKH lah.
Yeah.
So KK Hospital, there's a baby with a congenital heart deformity, right? So they scanned the patient, they 3D printed the heart out, right? And then they can cut open it, right?
Okay.
From the digital design, then they can actually look into the heart to understand what the problem is.
Wow. Okay.
Right, because now you have this technology to help you realize a digital footprint, right?
Yeah.
So now you can have a physical thing, you look at it, which means when they do the surgery, they already go into it knowing what to do. So you don't have to spend long hours doing it. or you don't have to go in to be surprised by, I didn't account for this.
Yes.
So it probably makes it safer for the patient as well.
Okay.
So that actually has been well publicized in Singapore quite a couple of times. So that's one area where you can do it. So we generally call this pre-surgical plan. That means before you actually do the surgery, there's a planning phase. So you can use models for that purpose.
I see.
Yeah. Some of the other instances could be sometimes patients get a bone fusion in the heel.
Okay.
It's very painful for the patient because that piece of bone is not supposed to fuse.
Okay.
Yeah. Right. So when the surgeon, let's say, needs to make a cut and he wants to separate the two pieces of bone, although they have the scans, but they would like it much better if they can look at the bone itself and try to plan for it before they actually do the surgery. So now with 3D printing, they can do it already.
I see.
Yeah. So if you go one level up, the next other use they use 3D printing for is they make guides, surgical guides.
Okay.
So, for example, I think you have heard or you have seen people with very bowed legs.
Yeah. That's
so
right.
it's a medical problem for such patients because after a while it affects the joints and then affects the hip. Yeah. So it causes a lot of problems long term. So you want to correct it, you make it as straight as you can. So in order to do that surgery, the orthopedic surgeon has to break the bone artificially to straighten it. But they will stabilize it with instruments. Yeah. So you still have to make a cut in the bone so that they can correct the shape. But because you know that, even though I take a front picture, but the bone is going 3-dimensionally, so there's curvatures 3-dimensionally.
Yes.
So now that they have this ability to visualize, they can 3D print a guide to make exactly the same cut that they plan digitally. So because in 3D you can see, right? You say, okay, I'm going to make a cut here to here. But if you don't have something to help you measure that cut actually on the patient, then your cut may not be as accurate as you want it to be. So now with these 3D printed surgical guides, they can put it on the patient during the surgery itself. Then they will cut according to the guide, remove the guide. So now you get much better accuracy when you do your surgery.
Wow, okay.
Yeah, so that probably gets better outcomes for the patient as well.
Wow.
Yeah, so that's the next level. Then if you go one more up, then you go into implants. So implants we previously talked about like titanium, non-absorbable plastics. So there is also a trend for those things going to becoming 3D printed.
Okay.
So those are the customized implants. Then if you go one step up, then that's where we are at. That means we make these absorbable implants. But because we also discussed about its ability to let tissue grow back, right? So we kind of call this a regenerative implant. So that's kind of our own terminology.
Regenerative.
We call it a regenerative implant. Then if you go beyond some more, there's actually 2 more levels. So one more level is they want to print a tissue completely with cells in it. Then they
That's possible.
From a research point of view, it's a very interesting idea. So right now it still stays in the research phase. There are some technology hardware that's already developed that can print cells. That means you can precisely say, this part I want this type of cell, that part I want another type of cell. So they can already do this pinpointing of location. Yeah. And then so that's like the tissue level. Tissue means maybe just one piece of one piece of the cardiac muscle or one piece of the muscle. Yeah. Then if you go one more, then they are looking at completely the whole organ, you print it out. So there are people actually who look at it. Can we entirely print on whole organ out and then just implant that? So those are probably a lot into the future because if you want to bring it out to the market, you still have to get past the regulatory compliance, right? So those are still being set up as we go along.
Wow.
So there's actually a lot of applications for 3D printing.
Wow. Technology. It's like there's a lot of uses already, but there can be more possibilities. So if you haven't heard of it, you heard it here first, and then if this does happen in the future, right, you come back here. It's from here. You heard it from here.
You heard it from eXpose.
eXpose, I heard it from eXpose.
Come back in I don't know how many years. Honestly,
Dr. Lim's mouth. Yes. Wow. And help us talk us through a bit then. How is a day for you at the office?
So a typical day for me would be a lot of meetings, but those are required lah, because the way we work in the company is probably slightly different from the rest. The culture that we try to create in the company is something that's very open. So if you visit our office, there are actually no rooms. So it's an open concept. So everyone has a desk, yes, but there are no rooms for managers. There are no rooms for the CEO. So everyone sits on the same kind of desk. And the only room we have is a meeting room lah. But otherwise everyone sits on a desk. And that actually helps us instill a culture of open communication channels lah. So I can walk over to my colleagues, maybe in the regulatory affairs department. I can hold a discussion with them. I can walk over to my production colleagues and I discuss something with them, to my sales colleagues, and so on and so forth. So my day would probably be littered with a lot of these meetings. Just to make quick decisions on how to progress on certain topics. Then if we need discussions, then we can hold them in the meeting room. So that would be mostly my day lah. I mean, pre-COVID, then I also spend quite a bit of time away from Singapore. So travel around, whether it's ASEAN to Europe or to US. So depending on the trips, then those will take up some of my time also.
I see.
I mean, the most amount of time I spend away from home is, I think there was a period of time over 12 months. Every month I was out somewhere. But for short trips lah. But every month I was somewhere. Every month somewhere.
Busy.
Wow. And Osteopore International has a production plant in Singapore.
Yeah, that's right. So we used to be located in Science Park. That's when the company was established. And then after that we shifted to this current place, which is at JTC.
I see.
Yeah, so they have a MedTech building.
MedTech building.
In Jurong. Near to Jurong Point. So that entire building is filled with MedTech companies.
I see.
Including ourselves. So we started off with one unit. Then we expanded into two lah.
I see.
So right now the one unit is completely a manufacturing and a production space. We had to do that because the team was growing, and also because of the efforts by our colleagues. Then the demand for products has also increased lah. I think at the beginning we were barely doing 1,000 products a year.
I see.
Right now we are doing about 2,700 a month.
Wow.
That's great to hear.
So it has gone through quite a bit of growth over the years.
30,000
a year.
Products a year.
I think this year we are heading to close to 30k a year.
Wow. So it's a testament to, I think it's the company's product or the company's
to the technology, and also to the people in it that actually put in the effort to make this whole thing work. Because you can have a pretty good technology, but if you don't have the people to bring it to the market, right, then that's not as effective because this is not a consumer good, so you can't sell it in a consumer way. You really have to communicate with the doctors. You have to speak their language. You have to make them see what is the value of the product that it brings to them, the hospital or the patient. So that one really needs to come true.
And you guys also recently won the Brand for Good award.
So we won it, I think, twice, if I'm not mistaken. So that part is actually the corporate social responsibility portion of the company. So we I think, as we discussed earlier, we really wanted to make sure that our products can bring some value, right, to the entire healthcare ecosystem. And I think that's where they felt that even you have a brand, you have published IP, stuff like that, but you are doing something good with it. So I think that's where we received that award.
I see. Because it's not often you get to hear companies, especially a medical device company, right, that does so-called win awards for being for community development or even for for the work that they do. So I thought it was quite a good
Yeah, no, we are
accolade.
happy to
Yeah.
be recognized for that.
for the recognition.
Yeah, yeah.
Wow, okay. And we were also talking about you guys employing disabled for
So there's
to the company.
a kind of an ongoing project that we are thinking about, and we want to see if we can realize that lah. Because we feel that there could be other ways we can contribute to society. So right now we tap on a lot of the internship programs. So we have interns from university, from polytechnic, from all imaginable
Institutions.
and backgrounds. So we have students from law.
Okay.
We had students from political science.
Wow, okay.
We had students from engineering, of course. Then we had students from design, just doing industrial design. So there are opportunities that we think would be suitable. And of course, some of these interns eventually become our employees and colleagues. I think right now the next phase is we are thinking whether or not we can reach out to maybe some of the disabled out there who need a job and can contribute positively. So that could be one thing that we are looking at.
I see.
That's great to hear.
Wow. Yeah, that's very, very good.
I mean,
initiative that you guys are.
It feels good to be able to help out.
Inclusive, being all inclusive and all.
So, ladies and gentlemen watching, if you know any disabled person who is able to do design, comment below, drop us a link, and we will get connected. We will get him or her connected to Osteopore International.
Yep. Please reach out.
Wow, learn a lot about what you guys do. And this
happy
made
to
in
share.
Singapore product.
Happy to share that Singapore actually has good technology.
I think it's not very well known to like the common public. So I was asking around my friends who are from biomedical engineering.
Oh, okay.
Yeah.
So like I was like, hey, you guys know about this thingy or not? Then like even like he commented that like, oh, like this is such a good thing. Like how come I didn't know about it? Even though he was like from like polytechnic biomedical engineering. So I mean he was quite interested. So I'm gonna share this episode with him. So
Thank you.
Yes. You can look them up. But like if for someone like him who's like interested, just as he enters the workforce and or this field, then what like maybe some pieces of advice that you can give to these sort of like interested people?
Okay, so I guess what we always look for as a baseline would be that the person has a general interest and passion for this industry.
Okay.
Because I think I mean to be frank, I didn't know what I wanted to do back then when I was their age lah. So I mean it would be really good if you have an idea of where you want. I think where you want to be. So for a large part of our interns that we've taken on board, actually quite a few of them have some idea of what they want to do.
Okay.
How they think they can contribute. And then we always have that conversation with them just to understand their motivation, what they want to achieve in life. I think probably now might be this idea might be a bit more obvious to a lot of the youngsters. So maybe you say, oh, I want to do this. So that actually helps us understand the person better.
I see.
I think the other part, of course, would be all the related technical skills that they have or they so that is one thing that we also look at to see if there's a good match between company and the intern student or even the potential employee. And then of course after that if they join us, then training will be provided on the job or whatever.
Okay.
Yeah.
Well, there you have it, ladies and gentlemen. Once again, if you are interested to look at Osteopore International or intern with them, we'll go to the link below.
Yes.
Check out their website.
Right.
Or hook us up in the comment.
And
we will hook you up with them.
Thank you so much.
So thank you
for
very much.
sharing with us about Osteopore.
Yes.
And also thank you to N Coffee for the coffee and the cakes from Always a Handful. And check out their Instagram pages, but also check out eXpose Instagram pages and our Facebook. Comment, any questions you have or anything you'd like to comment. And yeah, we'll see you on the next episode of eXpose Experience.
Bye.